Welcome back, and I so hope you've enjoyed working through the different topics on this Introduction to Natural Language Processing course. Of course, the field of NLP is huge, and there's always new things evolving and new things being developed. In this last chapter of the course, we'll be discussing deep learning, its applications, and where we think NLP might be going in the next decade. Before we start discussing how deep learning has impacted the field of NLP, let's first clarify what we mean by deep learning. This is just going to be a high-level introduction. We're not going to do any code, but if you are interested in creating your own deep learning models, there's a great course on the 365 data platform that I would definitely recommend. So let's get started. Unlike traditional machine learning algorithms, deep learning, also known as neural networks, are built to simulate the human brain and its structure and function. These neural networks consist of interconnected layers that aim to analyze data and uncover patterns. Neural networks consist of input layers, hidden layers, and output layers. Each layer receives its input, applies an activation function, and then passes it on to the next layer. Each layer consists of individual neurons, and the strength of the connections between these neurons, known as weights, determines the impact of these neurons on the final prediction. By adjusting the weights between these neurons through our model training, neural networks can learn from data and use this to improve their performance. There are several different types of deep learning architectures, each suited for different types of tasks and data. For example, convolutional neural networks excel at image and video processing by exploiting spatial correlations. On the other hand, recurrent neural networks use connections that can process feedback loops, so these excel at processing sequential data such as language for NLP. Training a deep learning model involves optimizing these individual weights of the neurons to eventually minimize the difference between the predicted output that our algorithms are giving us and the actual output that we're looking for. Deep learning has made remarkable strides over the past few years and really pushes the boundaries of what we thought would be possible. With the advancements of hardware capabilities, deep learning has become much more complex, able to handle massive amounts of data. It's a super interesting field and especially has amazing implications for natural language processing. So in our next lesson, we're going to be discussing how this relates to NLP and the advancements that have been made in deep learning with NLP over the last few years.